Here we're going to talk about level L, page 24b, the example question over here. So let's read through the question one by one and see if we can understand the example. So we have log base 1 over 3 of x minus 1 is smaller than 1. So we're dealing with inequalities. We're dealing with logarithmic equations and inequalities. First of all, if we look at this, you might be confused. How come as long as my base is 1 over 3 or it's a fraction, it has to be smaller than 1, and then the sign over here is flipped, right? So this attribute actually comes from the shape of the logarithmic. So let's take a look at the note over here. So the note says if log base A of x is greater than b. So it's very similar to this question. Instead, we're going to do greater than 1 instead, just as an example. Then, or I can actually do if, right? A is in between 0 and 1. So any fraction, let's say for example, 2 over 5, 3 over 4, 1 over 12, so on and so forth. Any fraction as long as is in between 0 and 1, then you will have this attribute for you to evaluate the inequality, which means that the x, which means it's your anti-logarithmic, is in between the base a to the power of the answer b and 0. Okay, so putting into a context over here. So let's say for example, if I have a question of this, right? Based on that, if I change this question a little bit, I have log 1 over 3 x minus 1 greater than 1 as an example. Then following the rule over here, which means that my a is actually right in between 1 and 0. And can I assume that 0 is over here, and over here this will be x minus 1, and then 1 over 3 to the power 1. So that's my assumption. And very importantly, we have the 0 here, right? Because the anti-logarithmic cannot be over 0, or cannot be smaller than 0. And we have the 1 over 3 to the power of 1, right? Which is a to the power of b. So with that being said, let's take a look at a graph for our logarithmic. So we have the log base 2 of x, and we also have the log base 1 over 2 of x. The difference between these two graphs, let's take a look at b and e. As you can see that if my base number is greater than 1, and it's actually trending upward, which means that the larger the x, right, going to the right side, the larger the y value, which means that my logarithmic is going to be larger. But for graph E, the larger the x, the downward trending for my y value, which means that if I have my base number in between 0 and 1, most likely what will happen is that this is that reversed relationship versus when my base is greater than 1, right? So very importantly to understand from what page 20a is trying to tell us. Okay, so let's go back to this question over here. So if we have this question over here, we have, since the base is 1 over 3, which is smaller than 1 and also greater than 0, right? So immediately I know that this anti-logarithmic, which is x minus 1, should be greater than the base 1 over 3 to the power of 1. That's just not shown over here. So this should be x minus 1 greater than 1 over 3 to the power of 1. So after my calculation, I can simplify it as x greater than 4 over 3. So that's my number 1, right? Based on the relationship of here. So since my anti-log has to be greater than 0, which means that the x minus 1, which comes from here, has to be greater than 0 as well, which means x has to be greater than 1. If x is greater than 1, also x is greater than 4 over 3, whichever takes the priority, definitely x is greater than 4 over 3, because as long as x is greater than 4 over 3, my x is also greater than 1. So as a conclusion, my x should be greater than 4 over 3. As the example over here, let's take a look at question number 2. My base is 1 over 4, which is in between 0 and 1, right? So then I know that it's the reverse relationship over here. So immediately I know that, okay, so x plus 2 here, right, should be greater than 16. How do you get 16? What's 1 over 4 to the power of negative 2? So that 1 over 4 is here, and that negative 2 is here. it's the most important thing is that figuring out the sign is very important. If, let's say, my base is greater than 1, which means that this should be smaller. But in this case, since my base is greater than that, that's why it's greater as well. Okay, so in that case, I just change the 2 to the right side, which I get x greater than 14. And as you know, that the anti-log has to be greater than 0, which means that x is going to be greater than -2, versus x greater than 14 and also x greater than -2, which comes first. Definitely x greater than 14, because as long as x is greater than 14, my x is also greater than -2. So my answer is going to be x greater than 14. All right, so hopefully this video helps you understand page number 24A. We can move on to the next one, page number 25A. Okay, so in this case over here, let's also take a look at our example. So we have 2 log number adding each other up. So don't be afraid of that. Immediately I know that this x and also this x minus 1 has to be greater than 0, right? So I write it on the side that because that's the anti-logs attribute, which you will see that somewhere over here as well. All right, then we will evaluate it one by one. So the solution over here is that we have the log 2, base 2, of x times x minus 1. You might wonder, Tony, where do I get the x times x minus 1 from? Again, looping back to what we learned before, if 2 log adding each other with the same base, so for example, log ab plus log ac, it will become log ab times c, okay? So this one, you can refer to the video that I made before. It should be very similar to this one as well, okay? So that's how and where we get the variant of log base 2 of x times x minus 1. So since we know that the 2 over here, the base is greater than 1, which means it's backward, right? So which means that the x times x minus 1, which is my anti-log over here, should be smaller than the base 2 to the power of 1, and whatever this number is, right? So that's the 1 here, and the 2 here is the base. Okay, so once that's understood, we move on to opening the bracket here. X squared minus x minus 2 is smaller than 0. We move the 2 to the left side. This one you guys should be very familiar with. And we're solving the inequality of the quadratic function. Very easy, all right? So you will get, if I were to draw anything, here, let's see. If I were to draw anything here to help me understand this, my 2 intersection will be -1 and 2, right? And my graph is going to be something looking like that. If it's going to be smaller than 0, which is in between -1 and 2, which means that it's going to be -1 smaller than x smaller than 2. That's how we get that. So once we know this is number 1, remember, we talk about how the anti-log has to be greater than 0, which is x greater than 0, x minus 1 greater than 0. So once we figure that out, the results needs to be x greater than 1. So as a conclusion from the x in between -1 and 2, and also x greater than 1, we will eventually get 1 smaller than x smaller than 2. So that concludes this video, and then the example that we talk about in page 25A. Hopefully this video helped you guys, and if you guys have any more questions, please let me know. Bye.